Okay, so addition and subtraction could share their own video, but multiplication and division each needed their own video. So let's start with some division problems here. Let's say 46,500, nice big whole number there, divided by 10. One way to approach this is through long division. 46,500 divided by 10. Now, I don't recommend this, but it will work. 10 goes into 4. No, it's too big. 10 goes into 40 4 times. 10 times 4 is 40. Sorry, 10 goes into 46 4 times. Remainder 6. Bring down the 5. 10 goes into 65. 6 times. 10 times 6 is 60. Bring down the 0. 10 goes into 50 5 times. There's 465. But then, okay, remainder 0. What about this 0? Well, this 0 is separating the ones place from the tenths place. So I need to show, is this 5 in the ones place, or is it in the tens place, or the hundreds place? Right? When you're doing long division, it's imperative, it's really important, that you put your quotient each time over what amounts to the ones place for those two digits. Right? 10 times 4 is 40. That's what we're lining up with the 46. We're, in some ways, ignoring the rest of this, saying 10 times 4 is 40, 46 minus 40 is 6. So 10 goes into 46 4 times. Right? That's why that 4 is lining over the 6, because it's a 4. 10 4 ones times 10 is 40, and that's pretty close to 46 with the remainder of 6. Now, if everything is lined up, this 5 is lined up in the tens place, I need an extra 0 here in the ones place to show that this is 4,000. So, having done all of this work, we get 465 0 instead of 46500, right? By dividing by 10, we get basically the same number, but it's moved over one spot on the place value. I was going to say on the number line, but moved over one spot in terms of place value. So let's see how we can make that work to our advantage here. 46,500 really means 465 hundreds. Right, those two zeros there mean I took this number and multiplied by 10 once and then a second time. Dividing by 10 means I'm now multiplying by a tenth. Right? Dividing by 10 means instead of getting 10 times bigger, I'm making it 10 times smaller. Well, those two cancel out. So I'm really just multiplying by a single 10. I went a little too far. Multiplying by a single 10, and that's how I got this number. Right? So the really super shortcut when you're dividing by 10 is you just move the decimal point back one spot to indicate that your original number is actually moving to the right one spot. Really, we're starting with 46500 point. I actually have to switch colors there. Point. And then shifting this to the right one spot, which is the same as shifting the decimal to the left one spot. Now here, maybe you might think that didn't make too big of a difference, but let's try a different number. 46,500, instead of divided by 10, let's divide that by a million. 46500 divided by a million. Well, a million doesn't go and do 40,000, so nonsense, right? This is 465 times 100. Oops, making that tenths. 465 times 100 divided by, how many zeros do I have here? 1, 2, 3, 4, 5, 6. So I'm dividing by 10. 1, 2, 3, 4, 5, 6 times. So, oops. 10 tenths is a whole. 10 tenths is a whole. So still have 465. But I have to divide by 10 1, 2, 3, 4 times. So I divide by 10 once, twice, 3 times, 4 times. And I put a 0 there as a placeholder. So my final answer, 0.0465, or if you like, 0.0465. Either version is acceptable. Now the shortcut for writing all of this and understanding all this place value stuff is to just say I'm dividing by 10 6 times. So I divide by 10. 1, 2, 3, 4, 5, 6 times. I don't even have to write any of this work. I just slide it over, put in the placeholder 0, and there's my answer. So the decimal place value system lets us multiply or divide by 10 really just by sliding around what place value we're at. 465 is still 465. So now let's look at some actual division with numbers here. 46,500 divided by 3. No, 46500 divided by 3. 3 goes into 4 one time. Let's actually make that smaller, just so it fits in better. 1 times 3 is 3. Remainder 1, bring down the 6. Right, 3 is just a one-digit number, so I only have to look one digit at a time. 3 times 5 is 15. Bring down this 5. 3 times 5 is 15. And I'm done. 155. But again, the decimal place is way over here. So I need to bring these zeros back up here, right? 465 divided by 3, if I ignore this. 465 divided by 3 is 155. But this was 465 times 100 divided by 3. So I need 155 times 100. Right? 46,500 is 465 times 100 divided by 3. Let's make that 100 look more like 100. There we go. Divided by 3. I can associate the 465 with the 1/3. That gave me 155 times 100. I just put those zeros on there. Now I wrote comma 0, 0. That's wrong. I don't know why it's erasing that way. Times 100. I don't put a comma in front of the two zeros because our commas go between the thousands and the hundreds place. I have to count over 3 places to get my 15,500. Now, again, to be clear, I'm not suggesting you write out this level of detail as you do the problem. What I'm explaining here is why I get 155 and then these two zeros just come straight up. Because they're just affecting the place value. They have nothing to do with the actual division. Now, a similar looking problem that you might even think is easier, because 2 is a smaller number than 3. Maybe you know your multiples of 2 better than you know your multiples of 3. This is actually going to be a little more interesting. 2 goes into 4 2 times, no remainder. 2 goes into 6 3 times, no remainder. Move to the 5. 2 goes into 5 2 times. 2 times 2 is 4. Now I get a remainder. I could have been doing this all along with the remainder part. If we don't get a remainder, I encourage you to just do what I did and move on to the next place value. But you can say 2 times 2 is 4. 4 minus 4 is 0. Bring down the 6. 0, 6, that's 6. 2 goes into 6 3 times. 2 times 6 is 2 times 3 is 6. 6 minus 6 is 0. Bring down the 5. Now 2 times 2 is 4. It makes it take up more space this time. It's kind of your call whether you put those 0 remainders or just hop over. Anyways, we're at the point where I have a remainder of 1. 465 divided by 2 is not 232. If I just do 465 divided by 2, 465 times a half, I don't get 232. I get 232 with a remainder. So I can't just separate out those two zeros. I really need 4650. I need one of those zeros. 2 times 5 is 10. Now I get no remainder. I really need 4650. 4,650, half of that is 2,325, right? Half of 50 is 25. Then times 10. Then this extra 0 just kind of sits there. So I had to use the 0, but it was there, so that's no problem. So let's see, let's write our answer down here. 23,250, 23,250. Right? Half of 46,000 is 23,000. Half of 500 is 250. Right? Maybe we could have done that problem in our head. But we want to see why we needed this 0 because it didn't go into this part evenly. That's also true when we have something like 465 divided by 2. Right? 465 is an odd number. If I do this long division, 2 goes into 4 2 times, 2 goes into 6 3 times, 2 goes into 5 2 times, with the remainder of 1. I get 232, and that 1 is still being divided by 2. 232 and a half. 464 divided by 2 is 232. That extra 1 still being divided by 2. But if I don't want a mixed number, if I want to think about this just in terms of the decimal system, there's no halves place on the decimal system. 2 is in the power of 10. So what I can do is take that 465 and multiply it by 10 tenths. So instead of 465, I can think of it as 4,650 tenths. 4,650 cut in half. Right, 2 goes into 4 2 times, 2 goes into 6 3 times, 2 goes into 5 2 times, 2 goes into 10 5 times. 4,650 divided by 2 is 2,325. But now I'm dividing by 10, right? I'm using the associative property. Multiply this by 10, multiply all of that by a half, and then finally associate it with the 1/10 by putting this 2,325 in the tenths place. Now, as you might expect, we don't need to show this fraction work. 465 is a whole number, 465. If I put a decimal point there, 4 hundreds, 6 tens, 5 ones, and 0 tenths is the same as 4 hundreds, 6 tens, and 5 ones, full stop, right? By putting this point 0, I'm not really changing the value of this, but if I ignore the point, it does look like it's 4,000, and I can keep on doing the division, right? That's how we're going to that's how we're going to divide with all decimals, is we just put as many zeros here as we please, bring down as many as we need. In this case, I only needed 1, right? By putting these zeros here, what I'm really doing is multiplying by 10 a whole bunch of times. And then at the end, I divide by just as many tens. So I put a 0, I multiplied by 10, then I move the decimal point back, and it's right back where I started. So let's try this with another divisor. 465, let's go back to black here, 465 divided by 8. Okay. If 2 doesn't go in evenly, 8's not going to go in evenly. So let's see what we get here. 4 goes into 8, but 8 doesn't go into 4. 4 is smaller than 8. 8 goes into 40 5 times. Remainder 6. Bring down the 5. 8 goes into 65 8 times. 8 times 8 is 64. So I could get the mixed number 58 and 1/8, but I don't want a mixed number. I want a decimal point. Now, I'll just put a bunch here so that I'm prepared. Not sure how many I'm going to need, but I'll put them there. Now I can go back to the long division. I bring down the next place value. 8 goes into 10 one time. 10 minus 8 is 2. There's a remainder, so I bring down the next 0. 8 goes into 22 times. 8 times 2 is 16. Bring down the next 0 because I have a remainder. 8 goes into 45 times. 8 times 5 is 40, and I'm done. Well, I had to use 3 of these zeros. I really had to multiply by 10 3 times. So now I'm going to divide by 10 3 times and put my decimal point basically right back where I started. So I don't have to really keep track of how many zeros I used. I just have to take wherever my decimal point was, and it stays there. So my answer here, 465 divided by 8 equals 58 and 125 thousandths, or 58.125. Well, what happens if our initial number is itself a decimal? Let's say 4.65 divided by 8. Well, that's not any harder. I still see 465. 465. 8 doesn't go into 4. 8 does go into 46 5 times, right? The long division is exactly the same, but instead of the decimal point starting after the 5, the decimal point is starting after the 4. So we didn't have to add 0.0000. The point was already there. And then I had added more zeros, right? So 6/10ths, 5/100ths, 0 thousandths, 0 10 thousandths, 0 100 thousandths. I get 5/10ths, 8 hundredths, 1 thousandth, 2 10 thousandths, 5 100 thousandths, right? I get 0.58125. And that red decimal point was part of this problem. The green decimal point is part of this problem. I just didn't want to redo all of that long division work. Now, if you're at all familiar with decimals, this probably seems very reasonable, right? 4.65, that's about 4. A little bit more than 4, divided by 8. Well, 4 over 8, that reduces to 1/2. So my answer should be probably a little bit more than 1/2 because I had a little bit more than 4/8. Is this a little bit more than a half? Well, a half is 0.5. It's a little bit more than 0.5, 0.58125. This seems reasonable for where the decimal point is placed. That's good because we followed the rules. I took 4 ones, multiplied by 10, 1, 2, 3, 4, 5 times to get 465,000. 465,000 divided by 8 is 58,125. Then I took 58,125 divided by 10 by just as many times as I multiplied by 10. So divide by 10 5 times. 1, 2, 3, 4, 5. There's my point. So I have 58,125. 100 thousandths. But I'm not going to write it as a fraction. I might say it as a fraction if I'm trying to be fancy. But once we get past tenths and hundredths, we often just say 0.58125 because it's just easier. So there's long division when we're starting with whole numbers, or when our first number, our dividend, is a decimal. What do we do when our divisor is a decimal? Let's start a new video to address that.